In calculus, derivative measure how function change. To make differentiation easier, mathematicians develop a set of rules called the laws of derivatives. These laws let us find slopes and rates of change quickly, without always going back to the limit definition. So, the first rule is the constant rule. If a function is just a number or a constant, the answer is, or the slope is, always equals to 0. C dx equals to 0. The dx is the operation when we are deriving, and the c is the constant. For example, we have 7 dx. The answer here is always equals to 0 because it has no variable and only has a constant. When no matter how the high or low the value is, it is always equals to 0. Like the rest of the example here, C and C, it is also equals to 0. So the second one is the identity rule. So this one, it's a graph of a straight line through the origin with slope 1. Since derivative measures slope, the derivative of x is always equals to 1. We have here f of x equals to x. This one, it is a identity function simply because it returns what input you give it. So we have here the examples wherein number 1, quantity x minus 7 dx. The answer here is what? Why? Because x is equals to 1 and the derivative of 7 is 0. So that is the final answer. Number 2, we have 3x dx. The answer here is 3 because it is based on the identity rule.
For the power, when x is raised to the power, bring the exponent down to the power and subtract 1 from it. For this example, we have x cubed dx. And to get the function of this, we will simply put it on 3x raised to 2 minus 1. And to formally put it in the final answer, we're going to put f prime of x is equals to 3x raised to 2. So we have our final answer here. And for the next equation, we have 6x dx. So we're going to simply do what we did in the previous function we have. We're just going to put 6x raised to 6 minus 1. And as we did before, we were going to put in the formal form, the formal notation we have. And prime of x is equals to 6x raised to 5. So we have here our final answer. But how about our exponent is in fraction? The first thing we will do is we're going to use the power rule, which is we're going to move the exponent in the front. It can be expressed like 5 over 2 x. And the exponent we have, we're going to subtract by 1. So we have 3 over 2. So the last step, or to get the final answer, we're going to 5 over 2 x 2. So this is our final answer.
For our last example, we have here a constant that is a fraction, which is 1 over 2. But just like we did in the other examples, we just have to simply pull the constant out and then multiply it by the derived function. So our first step is to bring down the constant, 1 over 2, and then deriving x raised to 6. You can derive x raised to 6 by using the power rule, which would equal to x raised to 5. So again, bring down the constant, and then multiplying it by the derivative of x raised to 6, which is 6x raised to 5. And after that, we can then simply multiply. We can turn 6 into 6 over 1 to turn it into a fraction. And whenever we are multiplying fractions, we just simply need to multiply numerator by the numerator and the denominator by the denominator, which should equal to 6 over 2. x raised to 5. But 6 over 2 can be expressed in lowest term, which is 3x raised to 5. That is our final answer.
For answer B, if f of x is added or subtracted to g of x, we will simply get the derivative of f prime of x plus or subtracted to g prime of x. For our first example, we have x cubed plus x squared dx. So to simply get the derivative of this, we will simply just get the derivative of each function to get the derivative of this. So for our first function, we have x cubed, which has the derivative of 3x squared plus the derivative of x squared, which is 2x. So this is the final answer. And for our second example, we have x raised to 6 minus 3x squared plus 5. So we'll first get the derivative of x raised to 6, which is 6x raised to 5 minus the derivative of 3x squared, which is 6x, because we first simply multiplied the exponent to the 3. So we have the 6 plus the derivative of 5, which is 0, because any constant number doesn't have a derivative. So this is our final answer. And for the third example, we have x raised to 5 minus 4x raised to 5. So to get the derivative of this, we simply get the derivative of x raised to 5, which is 5x raised to 4 minus 5 times 4, which is 20, raised to 4. So this is how we get our final answer.
Now, we move on to product rule. The formula is f of x times g of x dx. Now, for the product rule, f of x multiplied by g prime of x plus f prime of x is multiplied by g prime of x. We use product rule if the problem has two functions. Now, for the examples, the first one is 5x multiplied by 5x squared plus 10x plus 1. And the first part is, we can find the derivatives of both functions. So, the derivative of 5x is 5. We use the constant multiple rule. So, for the second part, the derivatives of this is 10x plus 10. We use constant multiple rule and constant rule. Now, if we get both of the given, we can now do the product rule. First is bring down f of x. Now, we bring down g prime of x. And for the second part is bring down f prime of x. And then the last part is bring down g of x. Now, in the both functions, we can multiply into this given function. So, 5x times 10x is equals to 15x squared. 5x times 10 is equals to 50x. Now, for the second part, 5 times 5x squared is equals to 25x squared. And 5 times 10x is equals to 50. Oh, sorry, 50x. And 5 times 1 is equals to 5. Now that Now that we distribute both functions, we can now add like this. 50 plus 25 is 75x squared. And the next part is the terms of x. 50 plus 50 is 100x. And just bring down plus 5. Now, here's our final answer. Now, let's move on to another topic. First step is find the derivatives of both functions. The derivatives of f of x is 10x plus 6, and the derivative of 2x squared plus 5x is 4x plus 5. Now that we find the derivatives of both functions, we can now follow the product rule. Now that we've been done, we can do for method on both functions. 5x squared times 4x is equals to 25x cubed. 5x squared times 5 is equals to 25 squared. Now, 6x times 4x is equals to 24x squared. Six x times 5 is equals to 30x. Ten x times 2x squared is equals to 20x cubed. Ten x times 5x is equals to 50x squared. 6 times 2x squared is equals to 12x squared. Six times 5x is equals to 30x. Now that we did the full method, we can now combine like terms. 20x cubed plus 20x cubed is equals to 40x cubed. Twenty-five x squared plus 24x squared plus 50x squared plus 12x squared is equals to 111x squared. X plus 30x is equals to 60x. And now, here's the final answer.
For our next rule, we have the quotient rule. We use the quotient rule whenever we are dividing two functions. Because when we are dividing two functions, we can't just simply divide their derivatives. The quotient rule states that high over low dx is equals to low d high minus high d low all over low squared. We can use this in our first example, x squared all over x plus 1 dx. The very first step when using the quotient rule is by identifying the high and the low. For our high, we have x squared, which is the numerator, and identifying the low, which is x plus 1, the denominator. And we just simply need to get the derivatives of both the high and the low. The derivative of high is 2x by using the power rule. And the derivative of low is just 1. Now, we just need to follow what the quotient rule states. Low d high minus high d low all over low squared. So, it would equal to our low, which is x plus 1, multiplied by the derivative of high, which is 2x, minus high, our high, which is x squared, multiplied by the derivative of our low, which is 1. All over, and don't forget when showing our solution to always add the low squared, which is the quantity x plus 1 squared. Next, we just simply need to multiply. First is by distributing, our first step is by distributing 2x to the quantity x plus 1, which would equal to 2x squared plus 1 multiplied by 2x is 2x, minus by x squared plus x squared multiplied by 1, which would just equal to x squared, all over the quantity x plus 1 squared. And now, we just have to combine the like terms. Currently, we only have 2x squared minus x squared. And do the operation, we will have x squared. And since 2x doesn't have a like term, we just need to copy it. So it would equal to x squared plus 2x all over the quantity x plus 1 squared. And that is our final answer. For our next example, we need to get the derivative of x cubed all over x squared. Just like we did in the first example, the first step in applying the quotient rule is by first identifying the high and the low. For this problem, we have, for our low, we have x squared. And our high is x cubed. Now, we just need to get the derivatives of both. The derivative of our low is 2x, while the derivative of our high is 3x squared by applying the power rule. Now, again, we just need to follow what the quotient rule states. By copying the low, which is x squared, multiplied by the derivative of our high, which is 3x squared, subtracted by our high, which is x cubed, and the derivative multiplied by the derivative of our low, which is 2x, all over low squared, which is x squared raised to 2. Now, we just need to multiply. One thing to keep in mind whenever we are multiplying a variable raised to a power like x squared and 3x squared is we just simply need to add the exponent as stated by the laws of exponent. So, x squared multiplied by 3x squared is 3x raised to 4 minus by x cubed multiplied by 2x is, again, simply add the exponents, and 2x has an invisible 1, so it would just equal to 2x raised to 4 all over x squared raised to 2. Now, we just need to do the operation, which is 3x raised to 4 minus 2x raised to 4. Which would just equal to x raised to 4. All over x squared raised to 2. I will just put here so extra space. But this can be simplified even further by distributing the 2 to the x squared. And whenever we are distributing a power to a variable raised to a power, we simply need to add the variable, which would equal to x raised to 4 all over x raised to 4. And with that, it can simply cancel, and it would equal to 1. That is our final answer. For the last rule we have is the chain rule. The chain rule is used whenever the given problem is a composite function, where one function is inside another function. It is notated by as f of g of x is equals to f prime of g of x multiplied by g prime of x. For example, for our first example we have here is the function x squared plus 1 raised to 3 dx. The first step in using the chain rule is by first identifying the inside function, which is x squared plus 1. For us to easily remember this inside function we need to substitute this function into the variable u. So we should write let u equals to the inside function, which is x squared plus 1. And we need to get the derivative of this function, which is du. It should equal to 2x by using the power rule. Next, is we need to derive this inside function. So u with the outside exponent, which is 3 dx. But since now we are deriving u, we need to change dx into du, which is basically deriving with respect to u. And by using the power rule, we should get 3u squared multiplied by du. Now, we just need to substitute the inside function to u, which should equal to 3u, which is the inside function, x squared plus 1, and don't forget the exponent 2, multiplied by the derivative of this function, which is 2x. But since this function is raised to 2, we cannot multiply it by 3. So we can only distribute 3 to 2x. So it would equal to 6x quantity x squared plus 1 squared. That is our final answer. For the last example, we have here the function 2x plus 3 raised to 5. Again, just like in the first example, we first need to identify the inside function, which is, in this example, is 2x plus 3. And again, substitute it into the variable u. So, let u equals to the inside function 2x plus 3. And get the derivative of this function, which is 2. Now, we just need to derive u. So, u raised to 5 dx. We change this x into du. So, u raised to 5 du. Now, we need to derive u raised to 5, which should equal to 5u raised to 4 by applying the power rule, multiplied by the derivative of u, which is 2 du. Now, we just need to substitute the inside function 2x plus 3 into u. So, it would equal to 5 multiplied by 2x plus 3 raised to 4, multiplied by the derivative of u, which is 2. And again, just like in the first example, this function is raised to 4. So we cannot distribute 5 into this. So we can only multiply 5 with 2. So it would only equal to 10 multiplied by the quantity 2x plus 3 raised to 4. And that is our final answer.